again, Honors Chem students, Mr. Kreister here with you again. This is an additional video, a short one for Friday, November 20th, 2020. You've already hopefully watched the intro video to today's schedule and do nows and what we are doing today, which is of course Lab 4.2, and then spending the rest of the time working on the review as we have an exam coming up this Monday. And that's what we're going to talk about in this video, in particular, what to expect from this exam. So let's get back to our do nows, and let me advance the screen here, and we will talk about the exam. So exam 4.2, which also includes some material from Unit 4.1. Now, as I glance through the exam, I want to say that about maybe about a third of the multiple choice questions come from Unit 4.1. In particular, I will talk about what material you need to review from Unit 4.1. Of course, that was on your exam 4.2 review assignment. I included 4.1 stuff on there for that particular reason. Because after taking that exam, I feel that some of that stuff needs to be looked at again because it's so interrelated to what we have been doing in Unit 4.2. So here's what you need to know about that exam. First of all, you're only going to be allowed to use a clean periodic table and a calculator. That is it. All right, that's it. So there are 44 questions on the exam. Of those 44, 36 are in multiple choice format. And again, included in those multiple choice questions are about a third, maybe so around 10 or 12 of those which come from a review of Unit 4.1, and these are what you need to know there. Knowing the contributions of Schrodinger and Heisenberg regarding the quantum mechanical model. Just those two individuals, Schrodinger and Heisenberg, so make sure you review them. And then the bulk of the questions from Unit 4.1 involve knowing all aspects of the quantum mechanical model, again, which includes knowing the names, descriptions, and values of all four quantum numbers. Okay, so what each quantum number tells you about the location and or motion of the electron, what values each quantum number can have, which of course are based upon the quantum number prior to the one you are dealing with, how many electrons can fit into an individual orbital, which I would hope you would know by now is 2. All right, individual orbitals are determined by magnetic quantum number. All right, so for example, in a p sublevel or an overall p orbital, there are actually 3 individual p orbitals because L equals 1 is a p, and so M has 3 values, -1, 0, and 1. And so there are 3 individual p orbitals, remember px, py, pz, each of which holds 2 electrons for a grand total of 6 electrons in an overall p orbital or p sublevel. All right. Make sure you know that. Some of you got confused on that on the last exam. I don't want that to happen again. All right. And then also how many electrons can fit into a particular sublevel, which we just, oops, sorry about that. Which we just, I don't know why my phone went off. I guess I forgot and left the ringer on. My apologies. But again, knowing how many electrons can fit into a particular sublevel, SP, D, F, etc., and how many electrons can fit into an overall energy level. Remember, there's a shortcut for that one. So, and then now our current unit, Unit 4.2. You need to know all the scientists and what they did who contributed to the development of the modern periodic table, which would include our early contributors, Dover, Reiner, and Newlands, and then our more recent contributors, Mendeleev and Moseley. Know the layout, both periods and groups of the periodic table, including the names of the periods, blocks, and groups that I gave you in class and that were presented in the notes. Make sure you know that. Know how the elements are related to one another within a period, as you go across a period, and within a vertical column, which of course is a group or family. Which elements are most alike in their properties? One's in a period or one's in a group? Well, I would hope you would say that those that are in the same group or vertical column, because remember, they share an ending electron configuration. So they share the same number of valence or outermost energy level electrons. And so that makes them very similar. In fact, when Mendeleev was working with the development of the modern periodic table, remember, he left blank spots in his periodic table where elements had not yet been discovered, but he predicted their discovery. And because he knew that the elements in the same group were a lot alike. And so there again, as I maybe draw a little example here. So if this is a particular group, and this element were discovered, and this element down here was discovered, but this one wasn't, and there was a big change there in mass. He thought, well, there's got to be something in there whose properties, mirror these, but are found somewhere in between the two, above and below it. That's exactly what he did, and lo and behold, he was exactly right. All right, so that's what we would still do today. All right, so make sure you know that. Now, elements in the same group are most alike. All right. Knowing the periodic trend and why, this all is based on Coulombic force. We've talked about that time and time again throughout this unit. For all the properties that we went over in class: metallic character, atomic and ionic size, ionization energy, electron affinity, and electronegativity. You will need to know the definitions of all of those and the trend, both across the period or up and down a group, for all of those as well. So make sure you study that. We went over it all. And then let me advance the page again. 8 out of the 44 questions will involve diagramming the electron configuration of both neutral atoms and ions. All right. So electron configuration, of course, we went over a lot in the Unit 4.1 and again in Unit 4.2 with the formation of ions, which of course involve valence electrons. Of course, metals and nonmetals do different things in regard to ion formation. And again, that is based on several factors, most importantly of which is Coulombic force. So, study your notes, assignments, and both review assignments. The one from 4.1 and again this one, a combined 4.2, 4.1, to help you prepare for the exam. This is another big one, and there is a lot to remember. Plus, I made a little note here. This can be redemption time if you didn't do as well as you wanted to on exam 4.1. So how do you want to continue on in the second quarter? Man, we're getting close to the end here. All right, we're getting close. Do you want to improve? You want to remain the same? Or do you want to decline? I hope none of you want to decline. But now is not the time to lose focus. Believe me, now is the time to step it up. All right, step it up as we get closer and closer to the end of the semester. So prepare accordingly. All right, prepare accordingly. So I think that's all you need to know. Again, all this list is posted in Canvas. It was yesterday, and you may refer to that anytime. It is on both the calendar and also on the answer keys page as well. So until next time, this is Mr. Keister signing off. Stay safe, everyone. Take care of yourselves. Stay focused, for crying out loud. Please stay focused. Keep working hard. You got an exam Monday. I want you to be ready for it. And also you have a mastering due Monday morning at 7:30. Don't forget about that. So till next time, folks, I'll take care and I'll see you later. So long.